Yeah, good morning, everybody. So, hope you are all fine today, Monday, beginning of a new week. So, today we will discuss what is value engineering, concurrent engineering, and reverse engineering, and what is the role of these topics in the design, or how do concepts like value engineering, concurrent engineering, and reverse engineering influence engineering designs. So three terms: value engineering, concurrent engineering, reverse engineering. How can we use this in the design? So some of the things are already discussed in the sense in other forms we had discussed when we studied design thinking, isn't it? So design thinking, in fact, involves many of these ideas. So, in brief, what is value engineering? Value engineering, I'll tell you, value engineering, when we buy some product, if we go to a shop and we buy something, we usually say it is worth, buying that. It is worth paying 1,000 rupees. It's worth paying. So that means what? The value of that product, according to our estimation, our calculation, isn't it? It is worth as 1,000 rupees. If you pay 1,000 rupees, it's not a loss. So from the that is from the customer's point of view, value of the product. Now from the company point of view, some company who launches this product, who sells this product, who markets this product, and initially they will design the product. When they design, the company which wants to launch, say for example, Samsung wants to launch a new mobile phone, isn't it? Or Apple wants to launch a new mobile phone. So they will have a calculation of their value. Or value engineering means they will take all the measures to increase the value of the product without increasing the cost. How can they keep the cost at a required level, and thereby, and along with that, how can the company improve the design so that the value of the product is increased, or the value perceived by the customers are increased? So when the customers perceive or see a very good value, they will purchase it. Then their profits will increase. So they will adopt so many techniques, so many methods in the design process to increase the value. So that is the value of the value engineering. So they will probably take feedback. They will get the design reviewed by experts. Multidisciplinary people will be involved in the design, and they will give their opinion, and they will take their feedback, and they will take their reviews, and thereby they will modify the design. So that is why this design thinking, now they include all these things, one way or other, directly or indirectly, it includes, because ideate, define, prototype, test, empathize is the first stage. So, and in the design thinking, we have studied that design thinking, the stages are not linear, isn't it? So they can go in parallel or one after the other. There is no predefined order in which the stages are to be executed. This we discussed when we discussed or when we studied design thinking. So there also the focus is value, to increase the value. So value engineering as a topic today we will study, even though its impact has been discussed already. Now concurrent engineering also similar. So design thinking, if you look at the various stages, they are not linear, so they can execute in parallel. So that is what concurrent engineering is doing. It is not sequential. So requirement, you have the empathize stage or requirement analysis, then you have initial design, then you have detailed design, then you have prototype. So they are not sequential. So that means you do not need to wait for the customer requirements to be completed till you start the initial design. They can go in parallel, or the initial design and prototype can go in parallel, and they can take feedback from one after the other, and thereby they can improve. So wherever required, they can improve. So concurrent engineering means people will be working on in parallel fashion. Different stages will be executed parallelly, not sequentially. Sequential means requirement or ideate or empathize. After empathize, ideate. After empathize, define, then ideate. So they are in a specific order. Concurrent means parallel. So that is the idea of concurrent engineering. And reverse engineering is what? Usually, we will have a design, then we come to requirement analysis, then initial design, detailed design, prototype, test, and finally the product is developed and the product is launched into the market. But what is reverse engineering? It is in the reverse direction. That means you take a product and you analyze the product, you dissect the product, you disassemble the product, and you come back to the initial stage or an analysis part of that. What is the use of this? Say, for example, you want to study you are running a company and you want to study the product of a competitor. You have competitors in the market and you want to study, because the company will not reveal the secrets to the other companies, no? So it will not be available in the public. So you want to examine what is the algorithm, what is the method, what is the process they are actually using. So what you have available, the products are available in the market, so you can purchase the competitor's product, and then you will reverse engineer the product. That means you will try to analyze the product, what is happening inside, which is the methodology, which process, how they have designed, how they have used, how they have finalized this design, isn't it? So that is the idea of reverse engineering, to understand the product. So you have a product in hand. So the normal design, what is that? You have a design, then from the design you go or you move on to the product. In the reverse engineering, what is that? You have a product in hand, and from the product you go in the reverse direction, so that you can understand what is happening inside. The purpose will be different. As I told, a competitor wants to understand the product or product of other companies, or this viruses and viruses, antivirus softwares and all. So virus will be created by somebody, and virus will be there. So we can examine the behavior of the virus program or worm program, and we can understand. So we have the code of virus, and we can understand, so that we can develop antivirus software, isn't it? Or you have a software in hand, you can understand the software and you can make some modifications. Say, for example, this debugging, usually students will conduct the debugging competition in some technical competition, or also in some tech fest or something like that. As a part of tech fest, they used to conduct a programming contest, debugging contest. This debugging contest is in one way, it is a reverse engineering, because you have a program and it is not working and there are some bugs in that. So what you have, you do not have any idea about what is the program, how it is doing, what are the functions used, what are the lines of code meant for. You do not have any idea. How do you get the idea? You have the code, and from the code you try to run it. You just examine the output, and then you try to identify the various modules in the program, and then you will try to understand the function of each module, each line. Then you will gain an overall idea. Okay, this is how this program works, and this is where the error is. Only when you understand thoroughly, you can find out the errors or flaws in that. Whatever meaning, that is, the purpose is different. Reverse engineering is that there is no single purpose. There can be different purposes. Those details we will see as we go through the slides. So that is a brief idea of value engineering, concurrent engineering, reverse engineering. I hope it is clear. Clear, no? Give your feedback. Yeah. So value engineering is a systematic process designed to focus and improve upon the major elements of complex or high-cost projects. It is a process that employs a multidisciplinary team of experts to develop recommendations aimed at improving the value of a project. In effect, value engineering provides a second opinion on the design of it. You have a design, you ask for a second opinion, and then you try to review it. The main objective of a value engineering study are to make recommendations on how to minimize total cost, construction cost, life cycle, throughout the life cycle. Life cycle means what? What are the stages in which the product goes until it is thrown, until it is recycled, or whatever the final decision. To reduce construction time, to make the project easier to construct, improve quality, and to ensure safe operations and environmental ecological goals. Value engineering process incorporates, to the extent possible, the values of the major stakeholders, their opinions of the major stakeholders, and they include designer, construction engineer, maintenance engineer, contractors, state approval agencies, local agencies, and the public and final consumers. They will try to take feedback from all of these stakeholders, so that we can improve the value of the product. Value, now definition of value. Value, what is the definition? It is as defined within the context of value is the comparison of the true cost of a project features to its worth to those involved. So value can be expressed mathematically in terms of value index. What is value index? Worth divided by cost. Worth or function. What are the function it provides? What are the quality it provides? And divided by the cost, actual cost. The function of an item is the specific work it was designed to perform. Function means the specific work. When we purchase a mobile phone, the function is we are interested in certain features, and whether those sometimes we may be interested in high speed processor or a good amount of RAM, or the design we are in. We want to have interest in design or battery power. We want to have a long lasting battery backup, or any other feature which you want to, any other software or hardware feature. So that is the function. And the cost refers to the cost of the item during its life cycle. So what is the manufacturing cost, and what is the cost actually the customer has to pay? The ratio of function to cost implies that value of the product can be increased by either improving the function or decreasing the cost, because it is a ratio of function to cost. So either by decreasing the cost, you can improve the value index, or by increasing the function, you can improve the value index. Project features with the value index of less than 1 indicate questionable value. If it is less than 1, that ratio, if it is less than 1, you can improve. There is a chance of improvement. These features would be a good candidates for further investigation in a value engineering study. Features with the VI, value index, equal to or greater than 1 demonstrate favorable results in terms of their value. They are okay because they are good, because its ratio comes to 1. These features would generally not be investigated. It should be understood that increasing the value of a project or feature does not necessarily mean cutting cost. It is not about cutting cost. Wherever required, wherever some extra expense required, you will try to reduce that. Otherwise, our focus is not on reducing cost, because sometimes while with reducing cost, the quality may be affected. We don't want to have that. We want to have the real cost involved. Along with that, what are the maximum value that we can provide to the customers? That is the idea. It's not simply reducing cost. No, that is not. That is simply a cost-cutting measure, but that is not a real method of value engineering. Value engineering actually how to balance the ratio with our customers being satisfied. Value could also be added by increasing the worth of the product to the involved parties without adding cost. Value engineering also called value analysis. Another term is value analysis. Part of the value analysis will require evaluating the multiple alternate ways that a project or product can accomplish this function. So maybe when you purchase, when you want to manufacture a hardware, you'll try to see what are the various ways in which I can manufacture this hardware, isn't it? What are the various ways in which I can solve this problem? Then I will try to if I do this way, alternative 1, what is the cost? If I adopt alternative 2, what is the cost? And which is better, alternative 1 or alternative? From the customer's point of view, from the company's point of view, we'll try to take feedback. We'll try to have analysis, isn't it? But thereby we'll try to have an optimum value. That analysis is called a value analysis. Value engineering is the review of new or existing products during the design phase to reduce cost and increase functionality to increase the value of the product. With value engineering, cost reduction should not affect the quality. That is very important. Cost reduction should not affect the quality of the product being developed. Value engineering costs related to production, design, maintenance, and replacement are included. For example, consider a new product which is being designed and is slated to have a life cycle of only 2 years. Suppose you want to have a product which is supposed to have a lifetime of 2 years. After that, we'll throw away. So what will happen? The product will thus be designed with the least expensive material and resources that will serve up to the end of product's life cycle, saving the manufacturer and the end consumer money. So you should only use those materials which should last only for 2 years. You don't need to use a very stable or concrete material which should last for 5 years or 6 years or more than 2 years, because anyway the consumer is going to use this for 2 years. So you can select those material which should last for only for 2 years. So thereby you can probably say this is one example. This is an example of improving value by reducing cost, because the material which lasts for 2 years might be less expensive as compared to the material which lasts for more than 2 years. So in this case, we have the idea, we have the knowledge that the consumer is going to use this only for 2 years. Then definitely you can go for those material which are suitable for a duration of 2 years. So thereby you can have some reduction in cost. Another example, a bottle of dishwashing liquid, we all use in house or kitchen, that becomes slippery after some of the soap has leaked to the sides. And this could be improved by redesigning the shape of the bottle and opening spout to improve grip and minimize leakage. So this improvement could lead to increased sales without incurring additional advertising cost or manufacturing cost. So whatever way, this is one example of value engineering. So you have a dishwash, liquid bottle already available, and then you are trying to improve the quality or improve the value of that dishwash, liquid bottle, so that it doesn't leak, or the leakage is reduced, or how can we hold even when it leaks? No, it should not slip from our hands. People will use this when it should not slip away. So that way, how can we improve the grip, and how can we minimize the leakage? How can we reshape the opening spout, opening that nozzle where through which liquid comes? That opening spout we can redefine. So this is in fact a value engineering, isn't it? Value is added, isn't it? So that is value engineering. Next one, concurrent engineering. Concurrent engineering, also known as simultaneous engineering. Another name is simultaneous engineering. It's a method of designing and developing products in which the different stages run simultaneously rather than consecutively. As I told, that the design thinking approach, we studied design thinking approach and the different stages, empathize, define, ideate, prototype, test. Then we have discussed and defined, identified that they are not linear, they are non-linear. So concurrent engineering is a systematic approach which can be achieved when all the design activities are integrated and they are executed in a parallel manner. It decreases the product development time and also the time to market. That is the advantage. It decreases the product development time and also time to market, because what is from the initial idea to the time it is developed and launched to the market, that time gap we can reduce. So leading to improved productivity and thereby reduce cost are also reduced because of the very nature of the method, concurrent engineering. Nowadays, concurrent engineering is becoming more important as companies compete in the worldwide market. Where every company is competing with each other. Like who is going to have the first sort of innovation into the market? Somebody who innovates, somebody who is pioneer in the design will normally be succeed. Whenever whoever launches the product for the first time, we'll consider them as like a leader. So that is how every company is competing with other companies to become the leader, to become the ruler of the market. So reduced time in product development process, higher product quality, lower cost in manufacturing process, and fulfillment of customers' requirements are the key factors to define the success of a company. So generally, success of a company or the success of a company lies in the success of the products. So how can we call, or when can we say that a product is successful? Reduce time in product development. The customers. Today we announced that we are going to launch. So the customers, we should not make the customers wait, indefinitely for long period, so 1 year, 2 years for the product to be launched. As soon as possible, till when the product is declared, as soon as possible, the product should come to the market. Then only company, the consumers will appreciate. Higher product quality we cannot compromise on. Lower cost, and also the cost should be affordable, isn't it? It should be according to the value. And we should fulfill the customer's requirements. So only then you can call a product successful. Now, produce excellent products. The concept of concurrent engineering must be implemented. It is called simultaneous engineering, or it's also called integrated engineering, simultaneous engineering, integrated engineering, or life cycle engineering, which is more a philosophy than a method. Yeah, why it's called a philosophy, we will see. The concept of concurrent engineering was initially proposed as a means to minimize product development time. So the method where each design phase mostly starts when the previous one has been completed is called sequential engineering. So this is an example of a sequential engineering. This is not concurrent engineering. This is sequential engineering. What is sequential engineering? Here you can see various stages. Market investigation, that is similar to analogous to customer requirement analysis. Second one, product design specification, conceptual design. Fourth one, detailed design. Fifth one, manufacture. Finally, launching and sale. So these are the steps in the product development with the serial or sequential engineering or serial engineering. So what happens here? Each design phase starts only after the previous one has completed. So that is the problem. Now, therefore, some problems which may arise during product development process may cause the need for the product to be redesigned, and this redesigning activity will increase the development time and cost of the product, because only when the product has reached the market and only then they get real feedback about the product. So what happens? They should go up, because anyway they have manufacturing is done, and so they should go back to the design, they should alter the design and have new manufacturing of the article items, and then say, so this increases the cost of development and also the time of development. The factors will weaken the competitiveness. These factors, they will actually weaken the competitiveness of the products. In order to improve the efficiency of the product development process, concurrent engineering approach must be implemented. That is not sequential engineering or serial engineering. So this is the steps in the product development with the concurrent engineering. So here the same steps as we have seen here: market investigation to sale. The same thing, like market investigation, product design specification, conceptual design, detailed design, manufacture, and finally sale. The thing is that it is not sequential. As you can see, the arrows, they are bi-directional. From one stage, you can go to the previous stage. From any stage, you can go to any other previous stage. So that is advantage. So there, at any point, just like you try to connect this with the design thinking approach, design thinking on various stages, just like that, you can have you can go back to previous stages. So whenever you think that there is a problem in the detailed design, you can go back to the conceptual design, or you can go back to the product design specification, and you can correct it. And whenever some issue you feel in the conceptual design, you can go back to the market investigation again, and you can talk to the consumer, and you can clarify it, and you can have the clarity and and that correct design. You can immediately design it, and then you can go to the detailed design and manufacturing and finally design. At any point when you feel some difficulty, when you are not confident, like when you see value engineering, whenever you think that there is some issue with the value of the product, you can go back to the design. You can go back to any stage, because they are concurrent, they are parallel, they are working in parallel fashion, and they are not sequential. So the same stages which you saw in the sequential steps, here they have been displayed as a parallel steps, and this is called concurrent engineering. They can be executed parallelly, and they are not sequential. In this method, all the activities in the product development process are integrated and run in parallel with the feedback when needed, and the information and concurrent engineering tools continuously flow along with all the activities in the product development process. Consequently, many of the problems which can occur under the sequential engineering process can be completely prevented after a proper consideration. Many of the issues, because sequential engineering is more like a static, there is no flexibility. But concurrent engineering, there is much flexibility, so that you can add more value to the product without incurring additional cost and without consuming more time. So time is reduced, cost is reduced, and the value of the product is increased. Why do companies adopt concurrent engineering? So first one is competitive advantage. Reduction in time to market means business gain, an edge over their competitors. Enhanced productivity, that is the second advantage. Earlier discoveries of design problems means potential issues can be corrected soon rather than at a later stage in the development. So as and when we discover some design problem, immediately you correct it. It's not that you have design problem, you go with that particular flawed design or faulty design. You will not go to detailed design and implementation. Whenever you think that there is an issue, you go to the previous stage and correct it, thereby enhancing the productivity. Decrease design and development time. Make products which match their customers' needs in less time and at a reduced cost. Next, we will see reverse engineering. Reverse engineering is an approach in which an existing product is analyzed. As I told, existing product is analyzed and another product is developed in light of the analysis. So after your analysis, you get some idea, then another product can be developed. The product that is analyzed can be your own product or a product from the competitor. In reverse engineering, a product is dissected or disassembled to find out in detail how a part works and why it is used. How a part works and why it is used. Why is it used? So this information, if obtained by this process, can then be applied to solve one design problem or develop a new product. Manufactured products can also be reverse engineering. The products are taken apart and dissected to learn and understand how they work mechanically why they work. So you have a machine, you try to dissect each machine into different parts and try to see what are the, say, or a motherboard or any electronic component, you try to identify some circuits, some diodes, some resistors, some capacitors, some transistors, and some functional components. Then you try to understand what is the function of this component in the motherboard, in the circuit. Then you try to understand, oh, this is the circuit is for this or that, why they work and what part they play in the functionality, and what is the role of this part. Reverse engineering facilitates variants of existing products. So you can have variants, so different products you can have. Improvements often come as people learn how something works and what could be done to make it better. It is only an analysis to deduce design features from products with a little or no additional knowledge. There can be little knowledge, so there can be no additional knowledge. As I told the example of debugging, debugging competition, you can have some knowledge like this is a program, or you can have no knowledge also, like you do not know what is the program and how it works, and then you try to identify the error. In some cases, the goal of the reverse engineering process can simply be a redocumentation of legacy systems. Legacy system means what? The system which have been in use for a long period, and we do not have, since this system has been there for long, and we do not have the documentation. So right now, what you want to have? You want to have a documentation. So what you have? You want to know exactly how this products work. So you can do reverse engineering, and you can try to identify how the system works. What are the various components? What are the elements in the system? What is the role of each part in the system? Then you can have a documentation. That is one example. Even when the reverse engineered product is that of a competitor, the goal may not be to copy it. Even you reverse engineer a competitor's product, you cannot copy it, because that will be protected by copyright. It will lead to legal issues. So the goal may not be to copy, but to perform a competitor analysis. So you want to analyze that, okay, this is the product, this is the method my competitor has used, and so I can improve it. I can use some other method so that I can overcome. I can make better products than my competitors. So programs are written, when you come to software, computer science, so that is our domain. Programs are written in a language, say C++, Java, Python. That is understandable by other programmers. But to run on a computer, we know the programs need to be translated to another program like machine language, which is by a program called a compiler. Machine language, we know ones and zeros. So compiled code is incomprehensible to most programmers, but there are ways to convert machine code back to more human-friendly format using a software called a decompiler. So you have a compiler to compile or convert or translate your high-level language to machine language. Now, when you get the executable file, I want to do the reverse engineering. I want to do the reverse engineering of the program of a competitor company. So I can use the decompiler software to get the actual program. So then I can study that. So that is the use of decompiler in reverse engineering. Use of reverse engineering, it may be a learning tool, because that may be the idea, because you want to study how this works, because it will increase your knowledge. As a way to make new compatible products that are cheaper than what is currently on the market. You want to identify, analyze one product, and you want to make a cheap product, because only when you know how this particular product has been made, you can think of alternate ways to implement the similar product, and to uncover undocumented features of commercial products. Undocumented features. What are the features which are not actually stated or documented of the commercial products? So this is one example of reverse engineering. A famous example of reverse engineering involves San Jose-based Phoenix Technologies Limited. That is a company based in San Jose, US, which in the middle of 1980s wanted to produce a BIOS for PCs that would be compatible with the IBM PC. IBM, at that time, IBM was so successful in computers, and they had the BIOS, So one company called Phoenix wanted to produce a BIOS that is compatible with IBM PC. So what happened? To protect against the charges of having simply copied IBM BIOS, the company Phoenix reverse engineered IBM BIOS. First, a team of engineers studied the IBM BIOS. At that time, it was about 8 kilobytes of code. Then Phoenix brought in a second team of programmers who had no prior knowledge of the IBM BIOS and had never seen its code, working only from the first team's functional specification. What did the first team do? They analyzed the 8 kilobytes of code, and they converted their understanding into some documentation. There's some functional specification, and that functional specification was given to a second set of programmers who have not actually seen the BIOS. The second team wrote a new program, new BIOS that operated as specified. So the resulting Phoenix BIOS was different from the IBM code, but for all intents and purpose, it operated identically. It did the same function, but the code was different. The mechanism, the method by which it achieved all these functions of the original BIOS was different, because this is the example of reverse engineering. How Phoenix engineers, they deployed two teams. First team reverse engineered the product and prepared a documentation, design specification, and that design specification was handed over to, why it handed over to second team? Because second team has not seen that. So there will not be any copyright issue, because even see first team itself, if they do the coding, then there is a chance that they may emulate, they may take some coding, they may have, so there may be there can be some similarity, so that might result in some legal issues. So in order to avoid that, they handed over this design details to a second team who has never seen the BIOS, who has never not seen the BIOS, never studied the IBM BIOS, so never part of the team that reverse engineered the IBM BIOS. So other companies, such as another example, Cyrix and Advanced Micro Devices, have successfully reverse engineered Intel microprocessors to make less expensive, less compatible Intel compatible chips. So AMD and Cyrix, they all have reverse engineered reverse engineered Intel microprocessor to understand how it works and to make cheaper microprocessor for Intel compatible chips. Scientists often use reverse engineering too. Another example, Human Genome Project. We have all heard of it. Is perhaps the most famous example of scientific reverse engineering, wherein scientists try to decipher human DNA to learn more about how we work as a species. What are the characteristics of human beings? They actually try to decipher, decode the human DNA, deoxyribonucleic acid, to understand the human characteristics or features of human being as a species. So this is an example of scientific reverse engineering. So why reverse engineering is used? The product and process improvement. Many software developers use reverse engineering to improve their own code or to improve interoperability between programs. So our own code, and sometimes I want to, there is some problem, I told the debugging. So that can be used in my own program also, because there is some problem or my software does not give the required performance. So what I should do, I should try to reverse engineer, like what are the various functions, modules, the codes, and try to understand where those programs or lines or functions are written correctly, or where they are achieving the required functions. So that is one example. Cyrix and AMD, we mentioned this, reverse engineer Intel's microprocessors to bring a less expensive competitive product to the market. That is a part of product and process improvement. Another example is cybersecurity. Cybersecurity, reverse engineering viruses and other malware is common practice for companies that develop security software, virus software or anti-malware software. They first need to decipher, they first need to understand the internals of viruses, how viruses affects file, how viruses corrupts our system. Only when we know the working, we can have, so that we can have antivirus. Like only when the doctors understand the disease, only when the doctors carefully examines the patient and understands and analyze the symptoms and disease, he can prescribe medicine. So that is the same. Similarly, when we understand how a virus infects, how a worm infects, how a malicious software infects our computer and network, only then can we think of some security software. So in that case, cybersecurity, we use reverse engineering. Reverse engineering is also used to find security flaws in software. Like some issues are there in the software, some security issues. People are able to hack into my system. So we can have a reverse engineering to identify the issues and flaws in the system. Software reverse engineering can help to improve the understanding of the underlying source code for the maintenance and also for the improvement of the software, also to detect and fix a software bug or vulnerability. In order to there may be vulnerability, there may be bugs, or we want to improve the software because right now our program is lengthy. So I just want to make it shorter and effective. So what I can do, existing code I can analyze thoroughly, and I can think of, when I understand what the existing code is doing, I can think of some replacement in a shorter format, or some short code or brief code with a small number of lines, with a few number of lines, with a few lines. So malware developers often use reverse engineering techniques to find vulnerabilities in an operating system to build a computer virus that can exploit the system vulnerabilities. This example was already mentioned. So this is all about reverse engineering. So I think this is clear. So today's class we discussed about value engineering, concurrent engineering, and reverse engineering. Any doubts? You can ask now. Thank you.